Hi everyone, this is Asha. I'm working as an assistant professor in the Department of Artificial Intelligence and Data Science. In this series, I'll be teaching the subject Design and Analysis of Algorithms. Each video will cover one topic in a clear and simple way. Let's get started. So today's topic is n-coins problem using backtracking. Before getting into that problem, what is meant by backtracking? Backtracking is a problem-solving technique which is used to solve recursive problems. See, when there is a problem, there will be some solution. Whether it is one solution or many solutions. It is not only one solution. So we have more than one solution. So we are going to derive all the possible solutions for a problem. You all might have played maze. So maze means we will be finding a path in case if that path is stuck somewhere or if we are unable to find, what we will do? We will do backwards. That is, we will move forward. That is backtracking. Okay. So when you observe the picture, right hand side picture, first I am starting from node 1. Then from node 1 I am going to node 2 to find a solution. So I have found a solution and that is success. Then from node 2, I am going to derive another solution, that is node 3. But here, after node 3, I got stuck. I don't have any solution. That means I cannot continue further. So I have to move back to node 2. Again to node 1. Again I am starting from node 1. Now my path is to 4. Node number 4. From 4, I am going to node number 5. But where I got again struck. So I am coming backward. This is backtracking. From 5, I am moving again backward. That is the position where did I start. So 5 to 4. Again from 4, I am going to derive another solution. I have a possibility, so I am trying that. But even after that, that is when I reach the node 6, there is no further solution. That means I have struck. So again I am moving backward. And I am coming to node 1 and again I am deriving one solution called 7 and at last at the node 8 I found a complete solution. So this is the process of backtracking. You are just moving to a path. If you are not finding anything, coming back to your original position, again finding a new path. This is backtracking. Now let us compare what is backtracking and branch and bound. See, both follows brute force approach. Both will generate state space tree. That is, in order to solve a problem, we will construct a state space tree. Using the tree only, we will be solving the problem. That means in both backtracking method as well as branch and bound method, we can construct the state space tree. But the approach is different. What is that approach? In backtracking, we are applying DFS, depth first search. That means starting from the root node, I will be generating it branch wise. Okay, but in branch and bound, it is following the approach called breadth first search. That means the order of node will be level wise. Level wise means if you have a root node, then all the immediate child nodes will be generated. Then only it will move to the next level. So this is level wise, but backtracking is branch wise. Fine. So when you observe this picture, it will be very clear. See, when you are when you observe the left hand side, okay, first it will cover the entire extreme left position. It will move node by node. When it reaches the last node where it is marked as pruned, that means we don't have further solution. In that case, it has to return back to the same position where it has started. Again, it has to derive. So this is called backtracking. Now with an example, I'll explain you how. So here our problem name is what? N coins. You all might have known chessboard, right? So this problem is based on chessboard. That is n into n board. A board will be given, n cross n board. Okay? A chessboard is given. Suppose if it is 8 cross 8. A standard chessboard will be of 8 cross 8. but we are reducing it into 4 cross 4 because we have to minimize the solution. We are simplifying the problem. So we are considering the n value as 4. So we have to place the queen in the board such that they shouldn't attack each other. Okay? How the movement of queen will be in the chessboard? See, queen has more power, right? So if it is placed in a row, it can move towards left as well as right, the entire row, as well as the entire column, as well as diagonal. That means if the queen should not attack another queen, means no two queens should be on the same row or same column or on the same diagonal. So this is our condition. So based on this, we are going to place the queen in the 4x4 board. That is 4 into 4. So we'll be having totally 16 cells. But why it is 4? Let us see. Now let us consider the value of n as 1. That means only one cell, one row, one column. That's all. So here I can place only one queen. Can we place any other queens? No. So that means the solution is what? Trivial solution. We cannot further proceed. So we cannot consider n as 1. Now let us try n equal to 2. So we are constructing 2x2 matrix. That means we will be having 2 rows and 2 columns. When I place Q1 in first row, first column, that is in the first cell, I cannot place Q2 on the same row, same column and same diagonal. That means there is no place for Q2, right? So no solution. Now let us consider n equal to 3. So in the first row, first column I am placing Q1 and Q2 is placed on the second row, third column. But there is no place for me to place Q3 because in first cell also, in third row, first column also I cannot place. Third row, second column means Q2 is diagonal and third row, third column Q2 is straight. So no solution. That's why we are going for n value as 4. Now this is the matrix. Okay, n equal to 4. That means we have 4 rows and 4 columns. Okay. We have 2 tables here. I have represented 2 tables. First look at the first table on the left hand side. In the first cell, that is in the first row, first column, I am placing Q1. When I place Q1 in the first cell, towards right as well as downwards as well as diagonal, no other queens can be kept. This is the rule of Q, right? Queen. So already I told you to reduce the size of the problem, we are using 4 cross 4. Fine. So the X mark represents that no other queens can be placed in that particular cell. Now this is on the left hand side. So see, for each row I have to place one queen. That is in first row queen 1, second row queen 2, third row queen 3 and fourth row queen 4. This is how we are going to place. So first row I have done it successfully. Next I am looking for the second row. So in the second row, third column is empty. So I am placing Q2 over there. But when you place Q2 over there, in the third row, what happens? Diagonally Q2 will come and attack. I will show you in the next picture. As I mentioned, Q2 will affect Q3. That is in the third row, I cannot place Q3. Now only one option is there for me. That is in fourth row, I can place Q3. Okay, now I have successfully placed Q3 without any distraction. That means no other queens will affect me or attack me. That is Q1 and Q2 will not attack Q3. So in that way, I have placed it safely in fourth row and second column. But only 3 queens I have placed. Totally how many queens I have? I have 4 queens. My intention is I have to place all the queens in the chessboard, which is 4 cross 4. Now it is unable to place queen 4. That means my approach is wrong. So we have to apply the backtracking method now. backtracking, what did I say? If the solution, if I am not getting the solution, if there is no solution, or if the solution is wrong, then we have to move backwards, backtracking. That is, we have to move to the same position from where we have come. So now what I have to do? I have to remove Q3 and Q2. That means first I will try to change the position of Q3. Okay. So in this picture I have shown you, like, I just made one small arrangement and I tried to change the position of Q2. Instead of placing in the second row, third column, I placed it in fourth column. When I place it in fourth column, I have a place, safe place for Q3 in third row itself. I am getting now a place in third row itself. Because what is our intention? Each queen should be placed row wise. Queen 1 first row, queen 2 second row, queen 3 third row and queen 4 fourth row. So I am getting a safe place for queen 3. So I am planning to place it in third row. So this is what I done in third diagram. Okay, that is third picture, third table. So now when I place queen 3 in the third row, second column, obviously all the cells are getting blocked because of the queen rule. So now there is no place for Q4. So again I have to apply the backtracking method. So now by applying the backtracking method, I have to remove everything like Q1, Q2, Q3, everything I have to remove. So earlier Q1 was placed in first cell, that is first row, first column. So remove that also. Now that means I am going back and I am starting from the beginning, backtracking. Okay. Now what happens? Instead of placing in the first row, first column, I am just shifting the position of Q1 and I am placing it in first row, second column. Okay, when I place in first row, second column, again you have to use the star symbol or into symbol and you have to block the cells where I cannot place any other queen. So this is what I have mentioned using the yellow color into mark. So in that cells I cannot place. So in the first table I have mentioned that. That is bottom first table. Then in second table, if you see, there is one place in second row itself. So that is second row, fourth column I am placing Q2 successfully. And in third row I am getting a place for Q3 also. So by applying all the condition of queen, successfully I have placed Q1, Q2 and Q3. Now there is one more place in fourth row. So let us see whether it is possible to place queen 4 or not. Yeah, I can place queen 4 successfully there because no other queens are attacking. Okay. Now after placing everything, we have to find the solution, right? We have to derive the solution. Now x1, x2, x3, x4 are considered as queens. Q1, Q2, Q3, Q4. Now in which position are they placed? That is in each row, in which position are they placed? That columns you have to mention. So in the first row, second column. So I am writing it as 2. Second row, fourth column. So 4. Third row, first column, 1. Fourth row, third column, 3. So our solution is what? 2, 4, 1, 3. But as I mentioned already, there is no only one solution. We have many possible solutions. That means I can construct a mirror image for this, right? So when I construct a mirror image for this, each and every queens will be just swapped. When you are swapping, the position of Q1 changes from 2 to 3 because it's mirror image, right? The position of Q2 changes from second row first column to second row fourth column. The position of Q3 changes from third row first column to third row fourth column. And the position of Q4 changes from third row third column to third row second column. Now same manner you just pick and write the column numbers. Q1 is in third column, so 3. Q2 is in first column, so 1. Q3 is in fourth column, so 4. And Q4 is in second column, 2. So these two are the possible solutions. That is 2, 4, 1, 3 or 3, 1, 4, 2. Now we are going to construct the state space tree by applying bounding function. What is bounding function? Bounding function is condition. So here condition is the queen should not be in same row, same column, same diagonal. Okay. So now I will try one by one. First I am placing queen 1 in first row. Already I mentioned you each queen will be placed in similar rows. Queen 1 in first row, queen 2 in second row, queen 3 in third row and queen 4 in fourth row. So first I am trying to place queen 1 in first cell, that is first row, first column. After placing that, in second row, second column, I am trying to place q2. When I am trying to place q2, it is in diagonal to q1. So definitely there will be an attack, right? So don't go further. Kill this node by applying the condition, that is bounding. Place the queen in second row, third position and check whether any queen 1 is attacking. No, there is no attack. So you can proceed. Now what is the next queen? That is q3. So obviously in third row we can place it. So first in third row, first column we cannot place queen 3 because already queen 1 is there. Next in second column, there is a place. I will try. Okay, so I am placing it over there. But q2 will attack it diagonally. So q2 will attack q3 diagonally. So I cannot place q3 in the third row, second column. So again I am trying for third row, third column, but q2 is already there. So I will try in third row, fourth column. Again q2 will attack q3 diagonally. So it is also not possible. So no position for placing fourth queen also. So that means third queen itself is in attack. So I cannot place fourth queen. So again we have to apply backtracking. Previously we have placed q2 in second row, third column. Now I am trying in fourth column. Second row, fourth column I am just placing q2. Okay, now that is x2 equal to 4. In the tree, the x value is nothing but the queen value. Wherever you are placing, you have to mention it. So now I am trying for x2 equal to 4. It is safe only. Now I am constructing a child node below that is x3 equal to 2. x3 equal to 2 in the sense x3 is what? Queen 3. So queen 3 is placed in third row, second column. That's why it is mentioned as x3 equal to 2. Look at the state space tree. Now q3 is also safe, so we will leave as it is. Now I am trying to place q4 in fourth row, third column. So that's why I have constructed a tree x4 equal to 3. Okay. But here what happens? 3 may attack x4, right? So there is no position for placing fourth queen, since third queen is itself in attack. So now again I have to apply backtracking. So kill the node q4. We cannot move further. So that means the node in the sense x4 equal to 3 should be killed. Again we have to move backwards and we have to start. Again I am moving backward. Again q3 is also not possible, since q3 position disturbs q4. I have to kill q3 also. So moving again to the same position. That is, I am applying backtracking. Now the position of q1 is changed. I am constructing a new path. That is x1 equal to 2. So x1 equal to 2 means queen 1 is placed in the second column. The value of x1 indicates a column. Okay. So now x1 equal to 2. So queen is in the first row, second column. Now let us construct x2 equal to 1. x2 in the sense queen 2. So queen 2 in the first column. But what happens? Queen 1 may attack it diagonally. So it is not possible. So kill that. Let us construct x2 equal to 3. x2 in the sense queen 2. So queen 2 is placed in third column. Second row, third column. But there also it is not possible because q1 may attack it diagonally. So again kill it, no further solution. Now I am constructing x2 equal to 4. That is, queen 2 is placed in the fourth column, second row, fourth column. As of now, it is safe. So let us see. As I mentioned earlier, each queen will take each row. So first and second are placed properly. Now below that I am constructing x3 equal to 1. That means the queen 3 is placed in the first column. So as of now, it is also safe. Next I am constructing x4 equal to 3. That is, queen 4 is placed in the third column. So it is also safe. It is not attacked diagonally or row wise or column wise. So I think we have derived the solution. Yes, we have got a solution. So in the blue arrow mark I have mentioned the value. x1 is nothing but queen 1. Queen 1 is placed in x1 equal to 2 means what? Second column. x2 equal to 4. x2 is queen 2. It is placed in fourth column. x3 equal to 1. Queen 3 is placed in the first column. And x4 equal to 3. Queen 4 is placed in the third column. So in each row, each queen are occupied properly. So as I mentioned earlier, all the queens are taking their own rows. First queen, first row. Second queen, second row. Third queen, third row. And fourth queen, fourth row. Now what is the solution? The answer is the columns where they are placed. So 2, 4, 1, 3. We have derived the same solution earlier, right? So using the state space tree also we got the first solution. Now we have to construct the mirror image. So mirror image is nothing but swapping of the position. So Q1 is already in second column. Now it will move to the third column as it is a mirror. And Q2 from first column, it will move to the last column in the second row. And Q3 from the third column, first row, it will move to the fourth column. And Q4 will also be swapped. So I have mentioned using the arrow mark. When you look at the picture, it will be very clear. So after movement, what will be the solution? Let us see. So the solution for the mirror image is 3, 1, 4, 2. That is, we are representing the position of the queen along with the column number. So third column, first column, fourth column and second column. So 3, 1, 4, 2. We have derived two solutions for this n-queen problem using backtracking method. So here the queen is placed in a 4x4 chessboard, that is 4 row 4 column chessboard, and we know the movement of the queen. So the queen will move straight, that is row wise, column wise as well as diagonally. So no two queens should get attacked. That means no two queens should be placed in the same row, same column and diagonally. So this is our condition. So based on the condition, by applying the backtracking method again and again, we have successfully and safely placed all the queens in the chessboard as they won't attack each other. Okay. So and we have derived two solutions also. After deriving the first solution, we took the mirror image of that and we have derived another solution. So the first solution is 2, 4, 1, 3 and the second solution is 3, 1, 4, 2. So this is what the procedure or the process of n-queen problem using backtracking method. Thanks for watching.